Hello everyone. In today's lecture, we will discuss another new concept of that in the transient state stability, that is application of that equal area criteria to the different infinite buses without the different conditions. Okay. So what is nothing but that just we have to discuss here the two equal application of that equal area criteria to the sudden change in the power input. Means what? We are just changing the sudden change in the power input, that is nothing but the mechanical power. Then what should be the application on that equal area criteria, or the what should be application on that the stability point of view. Okay, so let us discuss the first. As we all know that as in just showed as in the in this figure, that is nothing but the PA versus that is a acceleration power versus del graph, that is a power angle characteristic should be the drawn, and in that case that is nothing but this is the, and that is a accelerating power, that is a accelerating power is there. This is nothing but accelerating power. Okay, this is nothing but the pi we can say it is nothing but the pm, that is a mechanical power or the input power, and this is nothing but the pe. Okay, pe is nothing but the electrical power. Okay, so that electrical power is equal to the p max into the sine of del. Electrical power kya hai? It's nothing but the p max into sine of del. What is p max? It's nothing but the e v upon x. The v upon x is nothing but what? It's a p max. Okay, so in this condition, that is nothing but the area A1, that is from the A to the B, and then the B to the C. It is nothing but the accelerating area, and this is nothing but the deaccelerating area. Why it is deaccelerating area and why it is accelerating area? Because that PM should be is nothing but the PM. It should be more than what? It should be the more than what is nothing but the PE. Okay, PE electrical power से ज़्यादा है. That's why it is called as deaccelerating power. Means what? Mechanical power is more than the accelerating power, then it's why it is called a deaccelerating area, because in negative hai. It is in the negative point of view. Okay, and whereas in terms of the area A2, that is a here that is nothing but the area A2, that is nothing but the accelerating power, that is a PE should be more than what? PE should be more than that of a PI or PM. It should be more than that of pi or the pm. So for that case, it's a different acceleration or the positive graph is there, positive upward graph notation is there. So for that case, that area A1 and the area A2, that is a different A1 equal to the A2, that condition must be satisfied for the equal area criteria. So for that case, in accordance with the equation for the stability, the equal area requires what? Area A1 is equal to the area A2. So what is that equal to area A1? It's equal to del 0 to the del pi minus p max into the sine of del into the sine of del into the d del. Okay, del 0 say del del 0 to del 0 to del, that is nothing but the p1 area A1, and it is nothing but the area A2, that is del 1 to the del 2. Okay, del 1 to the del 2, and p max minus p max into the sine of del, that is nothing but the pe upon pi, and pi minus pe. Okay, p max minus sine of del is kya hai? Pa. So pi minus pe into the del sine into the d del, or pe minus pi into d of del. Okay, so just by simplification point of view, so we can say that is nothing but the pi sine I minus del 1 minus del 0 plus p max cos del 1 minus cos del 0 is equal to the pi del 1 minus del 2 plus p max cos of del 1 minus cos of del 2 by integrating point of view. Okay, so but the pi is nothing but what? P max into the sine of del. Pi क्या है? It's nothing but the p max, that is nothing but the pi क्या है? And that is a PM. Okay, so PM is nothing but the mechanical input power बोल सकते हैं इसको, या फिर mechanical input बोल सकते हैं. Mechanical input is nothing but the P max into the sine of del. अब P max into the sine of del, so we just replacing the PI with respect to the P max. So after application, we can say that this equation must be satisfied for the sudden change in the input, that is a PM. Okay, del 2 minus del 0 sine of del 1 plus cos of del 2 minus cos of del 0 is equal to the 0. Okay, so yeah, this is nothing but the criteria for that equal area criteria for the sudden change in the PM or the PI. Okay, sudden change in the mechanical input. That is a del 0 minus del 2 sine of del plus cos of del is equal to the 0. Means what, that d of del upon dt is equal to कितना चाहिए, 0 चाहिए for the equal area criteria. So from the above we can again say that for the unequal area criteria, that del 0 to the del PA into the d of dels is equal to what, is equal to the 0. That criteria must be satisfied. Means what, the area under the curve PA should be 0, which is possible only when PA is both accelerating or the deaccelerating power. Means what, PA area under the curve PA, area under curve, what is a PA curve, it is a little bit a PA curve. Area under the curve A1 and the A2 should be accelerating or the deaccelerating. Accelerating means what, for the part of the PA, that is nothing but the PA should be more than PE, and second is nothing but the PE should be more than PA. So for the generator action, accelerating power ज़्यादा रहेगी. For the deaccelerating motoring power, the deaccelerating power should be more. Hence the name is called what, the equal area criteria for the stable operation. Hence the name is called what, it's called a equal area criteria. Whereas area A1 represent the kinetic energy stored by the rotor during the acceleration, and the area A2 represent the kinetic energy given by the motor to the system. Means what, एक तो acceleration होगा, the second retardation होगा. So for the stability point of view, for both the area under the acceleration curve, it should be equal, and it should be noted that the kinetic energy involved is nothing but the friction is, and it's calculated to the relative speed rather than the actual speed. किसका है? It's nothing but one of the relative speed between the two machines. Okay. So this is nothing but all about the application of that sudden change in the mechanical input. Okay, so let us discuss the one of the example of that stability of that single machine infinite bus system के लिए अपन equal area criteria का use करेंगे. So for that case, just consider the one of the synchronous machine that is connected to the infinite bus. Okay, synchronous machine consider किया. Then उसमें अपन ने क्या किया, इनिशियली द मोटर इज सप्लाइंग द मैकेनिकल लोड. मोटर कितना लोड प्रोवाइड कर रहा है, दैट इज नथिंग बट PM0, दैट इज नथिंग बट इनिशियल मैकेनिकल इनपुट. मैकेनिकल लोड कितना है, PM0. while operating at a angle is nothing but del 0. Means what, PM0 कितने पे मिल रहा है, we are getting is nothing but what, del 0. Okay, so the speed is nothing but the synchronous omega s, neglecting the losses किया, is equal to the mechanical load applied. So okay, so means what, the input power is equal to the output power. So if the load of motor is suddenly increased, means what, that PM0 से अपन कहाँ पे गए, PM1 पे गए. Okay, so the at the same time sudden load demand will met by the motor giving it stored the kinetic energy, thus motor therefore the slow down. Okay, if the load of that motor should be increases, so automatically their acceleration power should be the decreases. Means what, their retardation or the deaccelerating power should be the increases, or their speed should be the lower down. अगर speed lower down हो रहा है तो torque angle increases from that del 0 to the del 1. So again, to reach that synchronization, what the condition should be, that del 0 to the del 1 should be implied. Means what, the first condition, that del 0 to the del 1 is implied when the sudden load changes is there. If the sudden load changes is there, so automatically what happen, that the angle should be shifted from the del 0 to the del 1. If angle should be shifted from the del 0 to the del 1, means what, acceleration should be carried out, and this is nothing but the retardation. ये तो हो गया उसका acceleration, and this is nothing but the retardation. So this is the arrow downward is shown as nothing but the deceleration, arrow upward is shown as nothing but the acceleration. Okay, this is nothing but the area A1, and this is nothing but the area A2. Okay, so next point, since the motor is deaccelerating, motor deaccelerate हो रही है, तो speed is less than ns at B point. The speed is nothing but the speed is generally what, it generally less than at a say less than synchronous speed. If it is less than synchronous, then the motor angle del is increases to the further del 2. अब कहाँ पे increase हो रहा है, उसका speed decrease हो रहा है. Speed decrease हो रहा है तो again it's increasing. Motor is again try to increase its speed, del should be increases to the del 2. So for the acceleration point of view, that at the point of view, that speed should be speed should be n r should be less than n s. If it is like that, that's why that del should be shifted to what, del 1 should be shifted to the del 2. Del 2 पे shift हुआ तो automatically their speed should be increases. That is nothing but the synchronous speed पे उसको rotate होगा. So that's why that n is equal to ns at angle is nothing but del 2, and the electrical P is nothing but greater than Pm at the point of C. So at the point of C, increase of the del is nothing but at the point of C, the increase of the del will reaches to what? Ns should be more, area under the PE should be more than is nothing but the Pm. Okay, it is more than Pm, and that torque start deaccelerating. Then the torque angle start decreasing till the del 1. Then again ये तो Pm क्या हो गया था, Pe should be more than at a point of C क्या हो गया, that Pe should be more, ये point पे क्या है, at a point of C that Pe should be more as compared to the Pm. So at that point, to again comes to the equal area criteria, the angle of that del should be again comes down to the del 1. Means what क्या है, पहले C पे जाएगा, A to the B, then B to the C, then C to the B. अब B पॉइंट पे आया तो उसका एंगल कितना होने वाला है, del 1. del 1 हो रहा है तो उसका एंगल क्या कम हुआ, एंगल कम हुआ, स्पीड कम हुई, automatically their power is very but the lower down. Power lower down, it's again equal to the area, that is A1 is equal to A2. Okay. Okay, hence the del decreases further till the point is nothing but n is equal to ns, but Pm is nothing but the P. So this cycle of oscillation is nothing but the continue acceleration, then synchronous, then deacceleration. So we have to change, or we have to change the del, that d del upon dt is equal to the 0 at d del upon dt is equal to 0 at a1 is equal to a2 point. Means what, the area under the curve acceleration is equal to the area under curve deceleration, and that cycle continues. This provide the system that is ready, but the single infinite bus connected to the single infinite machine connected to the infinite bus, उसका equal area criteria में application ये show कर रहा है. Okay, so but due to the damping in the system, the friction and losses, the rotor is brought to the new operating point at a P point. क्या हो गया, डैम्पिंग में क्या हो, न्यू ऑपरेटिंग पॉइंट, यहाँ से B को शिफ्ट करके वो यहाँ पे आएगा. अब यहाँ पे आ गया ताकि एरिया A1 का चेंज होगा, एरिया A2 का चेंज होगा. सो फॉर दैट केस in the figure the ABD represent the deacceleration, and the area BCE is a different acceleration. So this is a different deceleration, this is a different acceleration. Okay, so the motor will reaches to the stable operating point be only if the acceleration energy A1 is represented by the is equal to the deceleration. Means what, A equal represent the motor is stable kab hogi, when the A1 is equal to A2. Okay, so this condition should be satisfied when the d del by dt is equal to 0 for the any point of any value of del for the equal area with a sudden increase in the mechanical load on the motor occurs. Okay, so following point can be summarized from the above example, that there is a no change in the torque angle when the speed of the rotor is a synchronous speed. Means what, when the n is equal to ns, when n is equal to ns, then there is a no change in the torque angle. Means क्या, del में कोई changes नहीं होगा when speed is nothing but a synchronous speed. Second point, the angle increases in the case of motor, the mechanical will retard. The mechanical output means what, if the angle increases in case of motor, that is nothing but the PS should be more than PE, then the mechanical output is more than electrical output, then the speed should be low down. अगर angle increase होगा तो speed क्या होगी, goes down, but angle decreases, then the speed should be more than the synchronous speed. So this is nothing but all the observation we drawn from the single infinite bus connected, single machine connected to the infinite bus system applications. Okay, thank you so much. In next lecture we'll discuss the another some application with respect to the equal area criteria.